Okay, so I'm back with our next video, and this should be the last one for these slides. What have we got here? We're going to look at a different type of question that does show up on your homework this week, and look at this formula, or this question we have here, and I will remind you that we talked about compound interest. We used the formula P equals A 1 plus R over M to the MT. And I won't write all these down, but, sorry, I've got those P's and A's backwards. The amount is the principal invested multiplied by 1 plus annual interest rate divided by the number of compounds per year, M, raised to the power of however many compounds there are per year. And if we have, this is for annual, semi-annual, quarterly, monthly, daily, etc. And if you're compounding continuously, we use the formula A equals P, and this expression we don't use that. We use this number E to the RT. So we don't have to think about the number of compounding periods. We use this number E. And so we're asked here, use the continuous compound interest formula to find the time T in years, given that we have 89,000 as the value of the investment. And I guess I should have had a dollar sign here. I'm fired. 63,793 e to the, remember we'll express this in decimal notation. And now we're supposed to figure out how long this took. And it might not be obvious how we're going to solve that problem, but let's look at some things that we could do. One thing that makes sense to me is that if I divide through by 63,793, 63,793, I will get, and I'm not going to find this quotient yet, I'm just going to leave it in this form for the moment, equals e to the negative 0.074 t, and it might not be immediately obvious how to express that t as just one t because it's tied up in this e to this power thing. So it's time for a mathematical interlude. So let's talk about this for a moment. I want you to think about this statement for a moment. Go ahead and stop the recording. What value of n makes the statement 3 to the n equals 9 true? Well, I know that 3 times 3 equals 9, and I also know that I can write this as 3 to the power of 2. So n equals 2. Try it for these two as well. I know that 2 times 2 times 2 equals 8, and I know that this is 3 factors of 2. That's what the exponent means. How many factors of 2 are there? So n equals 3. And I'll happen to know that if I multiply 3 factors of 4 together, I get 64. So n, again, equals 3. So this comes up often enough that we give it a name, and it's called a logarithm. And it turns out that these two statements are equivalent. It means that they give you the exact same information. So if you have a number y that is a base b raised to a power x, and I want to write a couple things down here. B is the base, x is the exponent. Let's see here, I'll write it over here. B to the x is a power. And notice, there's the base, there's the exponent. And I guess what I'm saying is that you can think of a logarithm, as counting the number of factors in a given base. So that's what we were doing on this last slide. How many factors of 3 does it take to make 9? 2. That means that, so we could write these statements as log base 3 of 9 equals 2. See if you can write these in log statements. The base of this expression is 2, so I'm going to use log base 2. And n will be the exponent. And I'm asking how many factors of 2 are contained in 8. So n equals 3. This expression is a base 4. And I'm asking about how many factors of 4 are contained in 64. So that gives me 3. So the exponent is n, which is 3. And now back to the problem that we were trying to solve. It turns out that the base in a logarithm can be any positive number. We don't allow it to be 1 because otherwise it's not interesting. Since since 1 to the b equals 1 for all b, we don't allow b to be equal to 1. That's just not useful. But notice that the base of a logarithm can be any positive number. Well, holy crow. E is a positive number. So we can actually use log base E, and it comes up often enough that it gets its own name, ln. I like to think of it as logarithm natural. I actually really like to think of it as, like, with a bad French accent, logarithm naturel. And I don't know why I think that, but I do. So, and it makes me smile. Okay, so now we can solve this problem. And I'm just going to write it down again. So we have amount, 89,000, amount equals P e to the RT because of the continuous compounding. 89,000 equals 63,793 e to the 0.074 t. So let's start by dividing through by 63,793 like we did previously. So 89,000 divided by 63,793 is, alright, point, sorry, I'm struggling, 9513 7 9. We'll go one more. 8 equals e to the 0.074 t. And now we have a way to express the exponent not up in this e to the situation, because we know that the base of if you just look at this right hand side, the base here is e, so we know that this is log base e of this number, has to equal the exponent 0.074t. So now we can go back to our calculator and see how I left this expression in here. Now I have a ln key, calculate the natural logarithm. That is the natural logarithm. So we have 0.3329929 equals 0.074t. So we're going to take this number, divide by 0.074, and end up with t as 4 point, I think the problem where I got this one in 3 decimal places, so, but I didn't specify, so let's call it 4.5. And remember, that's years. So 4.5 years, about. So there's that. And like always, I hope you ask some more questions in the discussion forum, or send me an email or a text message, or give me a call. You have my phone numbers available on Blackboard. And there is a question or two about annual percentage yield, but I think this one is something that you can read and understand. I want you to read this and give it a shot. I will help you if you get stuck, but try it out. See how it goes. This hyperlink, I did test it. It actually worked. So this will take you right to where you need to go to read. And I hope that this video and all these were helpful.